Saxon Algebra 1/2, Lesson 116. Students, I'm tricking you. We already did 114. That was the probability with the independent events. Today we're doing our third lesson of the week, but I'm skipping lesson 115. There are other more interesting lessons that I would rather cover in this last week and a half, so we're going to skip over 115. We'll cover that next year, and you've already heard it all before. It's about polygons. 3 sides is a triangle, 4 sides is a rectangle, blah, 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 right? 5 sides is a pentagon. You've heard it all before. It's not that interesting. It's not that hard. I would rather just cover it next year and be done with it. We're going to skip ahead to 116. If you would like to grab your page like this and change that into a 6, then you'll keep it up to date. And then this we're going to change into a 7. We might as well change them all at once, right? Okay. And then the last week, it'll be 118, 119, 120, and then 121. Okay, so we'll have the same number of lessons. I just mixed up because we actually have more than 121. Or yeah, we have more than 121. We have more than 120. So I chose my favorite. All right, so this is lesson 116. You can kiss lesson 15 goodbye. When you're doing your homework, that means there may be some problems in here. Like when you're doing homework for 116, you may find a problem that looks unfamiliar. Check the little number in the parentheses. It may have come from 115. I'm just looking to see now. Yeah, there is one. There is one, lesson 115. You can look at it if you want, but you can skip it also. They're kind of common sense and fun. It's that thing where here's a weird shape and here's another weird shape. How can you make the first shape and the second shape match? How do you like mentally flip it over and twist it? My brain loves doing those. Yours might too, but you can skip it if you want. Okay, so skip anything relating to 115. Just a second, I have to readjust my angle. Okay, that's so much better. All right, 116 is about finding the area of parallelograms and trapezoids. And that sounds really hard, but it's super easy. And I just helped, let's see, this woman is a former student of mine. Her name's Hayden. I did math with her. Let's see, she graduated from high school in 2009 while you were busy being toddlers, I think. Or maybe even straight babies. She is now a teacher in Istanbul. She moved to Turkey. She teaches English online and is good friends with my third-born daughter. But you know how it is when you're homeschooling, your family's homeschooled together. It's kind of like you're all related. And she also does some math tutoring on the side. And she messaged me a couple weeks ago to ask me how to do this kind of problem because she was making it way harder than it needs to be. And when I told her how to do it, she was like, oh my gosh, that's so easy, I forgot. Okay, what does a parallelogram even look like? A parallelogram has 2 pairs of parallel sides, like that, right? And so John gives us this picture, and he gives us these numbers. They're fun to draw. And he tells us to find the area of this parallelogram, and he tells us dimensions are in inches. Okay, so I'm going to circle that. All right, so how in the heck are we supposed to find the area of this parallelogram? The easiest way to do it is to divide it into 2 triangles and label them A and B. Okay, I could have drawn from here to here. It works either way. My brain just kind of automatically goes from left to right. So that's the way I think of it. But it doesn't matter. Just divide it into 2 triangles. Now what we're going to do is find the area of triangle A. What is the formula for the area of a triangle again? Are you saying it? Say it right now out loud. I'm serious. Say it out loud. That's right. Base times height divided by 2. All right, so for triangle A, that's the harder one. We have to look at the base of it. The easiest way to do that is to imagine it flipping, right? I kind of imagine it like this. Do you see how I took that and kind of flipped it up? That helps me visualize, oh yeah, this is the base, and then this is going to be the height. The base then is 6. The height, which is the same height here, is 3. Divided by 2, and that is 18 divided by 2 equals 9. Okay, now let's do the area of triangle B. In a true parallelogram, it's going to be exactly the same measurements. It's going to be 6 here, that's the base. The height is 3 divided by 2, and we get 9 again. And then we just add them together for a total of 18 inches squared because it's an area, okay? In a parallelogram, the two triangles will be the same. In a trapezoid, the two triangles will be different. I can't always remember that rule, so I just approach it as if each triangle is going to be different, and then I'm pleasantly surprised in an example like this one where I realize, oh, it's the same number, it's fine. All right, we're going to do 4 problems in this lesson. Let's try the second one. Find the area of this parallelogram. No, 2 equal sides in this parallelogram are B units long. Oh, okay. Let me draw the picture and you'll see what I'm talking about. These are fun to draw because you try to make the 2 sides parallel, right? These 2 should be parallel, these 2 should be parallel. The trick in this one is that John is giving us letters instead of numbers, okay? So he wants us to use these letters to do this work because that's the way we can build a formula for ourselves. All right, fine, John. A, B. I have strong opinions about that, but we'll get to it. Okay, triangle A. We're finding the, the area of triangle A. I'm going to write area just so you're not confused. Again, it's base times height, and this time these letters are exactly what they're meant to be. There's the base. The height will be H, right? We kind of imagine this flipped up like that. That's triangle A flipped up. So this dimension is the same as this dimension. The base is B, the height is H divided by 2. The area of triangle B, I can see is going to be exactly the same. B times H over 2. And when I add them, as I did there, I'm going to get 2 times base times height divided by 2, right? Because there's 2 of them, 1, 2, so that's 2. And then look, the 2's will cancel. So the formula for the area of a parallelogram is base times height. Okay, that's right. If you want to memorize that, if you want to write it in your book and commit it to memory, that will work. You can do that. I personally prefer to just find the area of each triangle and not have one more thing to memorize. I've already memorized the freaking base times height divided by 2. I don't want to have to remember one more thing. Okay, so you have your options on that. Do it however you like. Example 116.3. Find the area of this trapezoid. Dimensions are in feet. Okay, now a trapezoid is different because it only has one pair of parallel sides. The other pair, these are supposed to be parallel. The other pair are not parallel. John tells us this is 6, this is 9, and then he makes this a square corner, and he tells us that this is 7 and this is 4. Okay, so we're going to do just what we did last time. We're going to divide this into 2 triangles. I'm going to call this A and this B. The area of triangle A, again, I'm just going to write it up here this time. Base times height divided by 2 is the area of our triangle. We know that, but, you know, brains go crazy. The base of this triangle A, again, if I want to, I can kind of visually flip it up. That helps me see that this is the base, 6. What's the height of this? Well, it's going to be the height of this, and that's 4, right? See how my eye can track? This 4 is going to be the same as this 4 is going to be the same as that 4. And then we'll divide it by 2. That's 24 divided by 2. It sounds like 12. Okay, so that's the area of the first one. The area of triangle B is, again, base. Okay, this base is different. That's 9. The height is still 4. And V divided by 2. I'm going to divide this first before I multiply, because I always like to make numbers smaller before I make them bigger. That's 2. 2 times 9 is 18. So I total it, I add them, and I get 30 feet squared because it's area. Yay, that's the right answer. These have all been the right answer. P.S. I don't think I've been smiley facing as I should. 18, let me just double check. 18, and this is correct. This is the formula, and that was the answer we were trying to find. Okay, yay. Trapezoids, there isn't a formula. You have to divide the triangles. So again, rather than driving myself crazy going, okay, which one is the formula and which one do I have to do by triangles? Because I'm always confusing parallelograms and trapezoids. Just do them both the same. You'll never go wrong with that. Okay, and oh, now here's a really big, crazy formula for trapezoids. This just drives me crazy. Use 2 triangles to find a general formula for the area of a trapezoid. So John draws us this picture. This is base 1, this is base 2. In a parallelogram, they're the same. In a trapezoid, they're different. And then he gives us this little picture, and he tells us this is H. Notice that we don't need to know that number. John gave us this up here, this 7. That was a red herring. It was just meant to confuse us. We don't need it. We do need the H though. Okay, so to find our 2 triangles, A and B, A is going to be base 1 times height divided by 2. B is going to be base 2 times height divided by 2. And when we add them, we'll get 2 times, now these aren't the same, so we don't get to add them. 2 times base 1 height over 2 plus base 2 height over 2. No, that 2 isn't right because we don't have 2 of anything that matches. We just have those 2 things together. And if we want, we can factor the H over 2 out of each term, and we get B1 plus B2. Yes, this is the area of a trapezoid formula. If you want to break that in the cover of your book and memorize it, cool. I personally don't. I think these area formulas for parallelograms and trapezoids are a needless complication. Just divide them into triangles and add it. It's so much easier. That is the end of our lesson. P.S. I considered skipping these 2 problems that focused on finding the formulas. I want you to see how easy it is to create it if you want it, but I also want you to see how completely unnecessary these formulas are. So as far as I'm concerned, you need never use them again. You can just throw them out of your mental window and work these problems using my triangle method. You'll always get the right answer, I promise. All right, that's it. That is lesson 116. We're not doing 115, so this is now donezo. Okay, I'll see you for 117 at the end of this week, and we'll just be weirdly off. Okay, goodbye.